One of the techniques that the Department of Geophysics at Cambridge had specialized in was seismic refraction shooting. That is, making explosions in the surface of the sea and measuring or recording the sound waves that had traveled down to the bottom of the ocean, been refracted along the layers of sediments or of rocks, and were recorded on sonoradio buoys, which were laid out in a string some distance from the ship which is doing the shooting. These buoys then would radio the arrival of sound recorded on hydrophones. It would be radioed back to the ship and recorded on a recorder so that one could then see the time that's taken from the explosion to the time it gets to the buoys. And from this you can deduce the structure of the ocean crust, the typical velocities of the sound in sediments and of the rock layers beneath the sediments, and indeed determine the thickness of the ocean crust. For a sound source, we used an explosive called Geophysics. These, I think, are 25-pound charges. They are, in this case, a total of 50 pounds, lashed together. And here the detonator is being placed in a hole in the Geophysics explosive. Discovery had been built with a special ammunition locker where we kept up to maybe 5 tons of Geophysics. The platform for launching the explosive was right on the stern. John Cleverley on the right is communicating with the bridge via the walkie-talkie. Dick Burt on the left is standing by to light the fuse, and once it's fizzing away, then the charge is sent over the stern. And the data is recorded on a recorder, multi-channel recorder. Each of the hydrophones on maybe 4 or 5 buoys sends its signal back to the ship. And from the paper records that generate from this machine, measurements can be made of the time, distance recordings. This is a slightly larger charge, 75 pounds. Weigh, charge. Then one had to find the buoys again. Of course, they may be 20, 30 miles away initially, but recognized by their flags. The buoys were then picked up. It's me in the foreground again, Di Davies on the bottom left, Bob Whitmarsh on the far side in the blue shirt, and Tim Francis, who was largely responsible for the working up of this seismic refraction work. That's Tim without the shirt on, and Bob Whitmarsh. The Sonobuoys, of course, have to have very carefully sealed waterproof seals, and the equipment is inside. you'll notice that everything, as you bring it on the ship, has to be lashed down. The ship, of course, is always moving. There is always the chance of something falling over, so it becomes automatic to lash things down. And the internals of the Sonobuoy connected to batteries which sit right at the bottom, and they're just disconnecting the power leads. By this time, as well as having radio transmissions sending the signals back to the ship, the signals were also recorded in the buoy using a 35mm recorder. This was before the days, I think, of digital recording in any form. There is the camera that is recording the output. Sometimes we operated with two ships rather than one ship for seismic refraction, and HMS Owen, one of the hydrographer's survey ships, was made available to fire Chodges, and this enabled us to operate longer range seismic refraction lines.